This episode will explore problem number 3, the concept of dark matter's additional attraction being used to solve the observed shortfall of general relativity at the galactic scale. We're going to go beyond calling things illogical and start showing how things are wrong with today's gravitational theory. The depictions shown represent the data of a typical galaxy that resembles the data from the Milky Way. The data from all galaxies is not identical, but they all exhibit the same problem shown in the graph. Clearly, the velocity of the stars does not match the calculations of general relativity. The circular depiction on the left represents the area of a typical galaxy. The stars that are shown in a line are really dispersed throughout the galaxy, but showing them in this manner makes their distances from the center clear. This also makes it easy to compare to the graph of velocities and distances. The current understanding is that there is some unknown matter that must be contributing enough added attraction to make general relativity work at the galactic scale. Gary's research has found multiple discrepancies with this concept. The reason we are presenting information similar to the Milky Way is because we have more localized data from the solar systems in our galaxy. The current observations of all known galaxies use the data of stars that orbit in close to the large mass at the center of that galaxy to accurately determine the mass of that object. That object is currently referred to as a supermassive black hole. Gary considers this supermassive object to be a gravitational dark star, GDS. These calculations do seem to be quite accurate. There is no added attraction required to make these calculations work. If you look at the graph close to the center mass, general relativity's calculation match the observed velocities. Let's add in problem number 6 that shows galactic conflicts at localized circumstances. If you look at the star that is circled in both depictions, it represents the position of our sun and solar system approximately 26,000 light years from the Milky Way's center. There is no additional attraction of dark matter required within our solar system because this is where general relativity's calculations were developed. Also, from our solar system, astronomers look outward at other solar systems within our galaxy to find planets. When they find a planet, it always orbits its star in accordance with general relativity's calculations. General relativity seems to work correctly in all solar systems, and also in close to all centered masses of galaxies. But the overview of every galaxy does not comply with general relativity. If you're going to insert additional attraction to the overview of a galaxy, you must insert additional attraction everywhere in that galaxy. The graphs show the need for dark matter near the solar system, circled where we know there is no additional attraction needed. This concept is just putting a Band-Aid on a major problem that is like a broken arm, and a Band-Aid will not fix a broken bone. The term dark matter's additional attraction is wrong. There is no additional unseen matter or its attraction anywhere. The only word that is correct is dark, because it means they do not understand the problem. Remember, general relativity is only useful at the solar system scale and instances like it. It is not useful for any other scale because it is using the wrong medium to transmit gravity's attraction. We now know dark matter is not the correct solution to this problem. Without this supplemental force, we now also know that general relativity is incorrect at the galactic scale. The alternate solution is the reservoir of free gravitons, which we talked about earlier. It needs no additional attraction at the galactic scale. The free graviton reservoir is rotating at a speed identical to the observed velocities of the stars shown in the graph. The free graviton is what transmits or conducts gravity as Newton thought. And within the reservoir, it operates without a conflict of traveling faster than the speed of light. The graviton reservoir is in place waiting for the planet's orbits to arrive, just as Einstein's curvature of space-time was designed. Before we move on to explain in detail how the reservoir of free gravitons works, we need to discuss a couple more items. Let's imagine there is a star within sight of Earth that goes supernova and creates a nebula. That nebula gets blown out and appears as a dust cloud in our sky. Hundreds of years later, this nebula is still in virtually the same position in the sky, even though we are moving at 440,000 miles per hour. The nebula was blown free from the star that went supernova, but it is still matching our speed around the galaxy as it coalesces. In a later video, we will further explain how it attaches itself to the reservoir to immediately keep pace with the galaxy. Without general relativity, there can be no black holes. In fact, these objects need to be referred to as GDS because they are completed neutron stars. Keep watching to learn how the perspective presented in this series begins at the molecular scale and goes all the way up to and including the galactic scale. This solves every problem without any supplemental forces.